All right, welcome back to our sort of short lesson on creating auto-generated levels. When we left off, we had actually gotten to the point of having an auto-generated level. In this section, we're going to finish it up. We'll get it so that our player here is out in the middle of the level rather than off to the side here, and we will also put in some enemies and plants and everything else. So let's get going. So open up your O level object and go into the create event. This is where we've been working all along here. Let me expand this out so we can see things a little bit better, and also see about increasing the size of this font a little bit here. There we go. All right, so we're going to come down into the section we just set up where we are showing specific tiles. Right? What do I want to do first? Well, I would like to place my player out into the room, so I guess we'll leave this section for a moment and let's go elsewhere in this script and take care of putting our player out here. So up near the top where we're setting up a collection of variables for our controller and how many steps it's going to take and so on, let's go right underneath here and let's take care of positioning our player. So position the player. And to position the player, we just want to get the player to be sitting out in the middle of the room, because the middle of the room will always have a floor tile in it, or will always be open floor. That's how we set things up, right? We placed our controller into the center of our data grid. We had the controller say, this should be a floor, and then begin walking, so that's how we know that's going to be a floor. So I'm going to create a local variable that I'm going to call player start x, and I'm going to set that equal to controller x times, and now why am I going to times this? So we've set up a controller x and a controller y. We're setting those values equal to the width of our grid divided by 2 and the height of our grid divided by 2, which is essentially giving us a position in the middle of our grid. But now we need to convert from the position in the middle of our grid back to a position in the room, right? So we're making the transition from a data structure back to pixels, to space inside our room. And we can do that by saying cell width plus cell, oops, not height, cell width divided by 2. Right? So what that's going to do is going to take our position in the grid, multiply it by 32 in this case, and then we're going to add 16 to that. And the reason we're adding this 16 is because of the origin point we have on our player. That will just make sure it's positioned well within the sort of cell in the room itself. Okay? Let's copy this to save ourselves some time and paste it here, and we want to have a player start Y position. I can type, there we go, and we're going to set that to the controller Y position, and cell times cell height plus cell height divided by 2. Right? So that gives us our player X and our player Y are positioned and converted back into pixels. Now we need to actually update our player's real X. So we'll say O player, that's the name I gave to my player object, dot X equals player start X, and let's be lazy, copy that and say player dot Y equals player start Y. And then in playing around with this, I found that if I added 16 to the Y, that seemed to work well. And the reason that worked well is that our player sprite is not a square. It's more of a tall rectangle. So I want to modify the Y position a little bit to take that into account. So I'm going to try this out, this should place our player out into the middle of the room and not have them stuck inside a wall. And we may have to do a little adjusting. So hey, look at there, there's our player. Well, boy, he doesn't get to move very much. Why is that? Why do we have, in some cases, very few, and in other cases, a whole bunch? Well, in my case, I think it's because I made the dimensions of my room big. So if I go in here and take a look at my room dimensions, I've got a room. Let's see our properties. Well, it's 800 by 600. It's not that big, but it's still just not looking right. So I'm going to play around a little with this, and we're going to do a couple of things to clean this up so that our level looks a little better. I'm going to go back into my old level, back into the create code. Let's expand this out so you can see it a little bit better. And I want to do a couple things. Well, we're going to do a few things, but first, one item of cleanup. What I'm going to do is down here is where we're setting up our tiles, right? And in this section, I'm going to take all of this and I'm going to copy it. Okay. And paste it here, and what I'm going to do in this section is I'm going to do a little bit of cleanup, and it's going to use essentially the exact same code we did before. So it's not super efficient because we're going to end up running this same code twice. Right? But what I want to do first is I don't want to have a situation where we have just a little bit of floor with walls surrounding it, because it kind of looks odd. And so before I go in and place the specific images from our tile set out into the floor, I want to clean up the grid itself using this same bit masking method. Okay. And what I'm going to do, instead of setting a specific tile, is I'm going to say if tile index equals 1, then I'm going to update what is stored in the grid at that location using this accessor hash symbol at our current location, and I'm going to set it equal to floor. Now this is super confusing, I know, but basically what this will do is it's going to identify cases where we could potentially have just a little hunk of floor with a bunch of walls around it, and we don't want that, okay? So before I do anything else, let me show you the effect that this has. All right. For one thing, it's making our dungeon much more open, right? And it's also preventing cases where our player might get stuck in like a little closed off chamber. Okay, that looks pretty good. Another thing I want to do is right now we can just wander through the walls. There are at least 2 ways to fix that. One way is what Benjamin Anderson does in his set of videos, which is to create a collision detection system using the grid that we've set up to detect if the player is about to step on a tile. And if they're about to step on one of those wall tiles, then it would stop them. We're going to use a simpler version than that. And in our version, all we're going to do is going to set a wall object, the same wall object we used for our RPG game, wherever there is a wall tile. So if I come, here's this first section where I should say, clean up the grid. And then we're going to come down to the second one where we're actually showing some tiles. And down here, right after we choose and display a wall tile, the correct version of a wall tile, I'm going to instantiate a wall object in the same location where we place one of those wall tiles. Makes sense, right? All right, so in this location, we will, we're going to say instance, create layer. This should be familiar. Instance create layer. And where are we going to place the instance? Well, we want to go where our X is times cell width. That's going to convert our position in the grid to the pixel coordinate out in the room. Okay. For our Y, we want our current Y position in the grid times cell height. Okay. And what layer do we want to place it on? Well, in my case, I have a walls layer out in the room. And what object do we want to put there? We want to put an instance of the wall object. Okay? So it's going to place an image from our tile set there, and then it's going to throw a wall object in that same spot. Let's try that. Now our player, well, he's a little stuck, so we're going to have to, we'll have to play around a little with his positioning. You see where he's kind of stuck in there? That's because of the size of his collision mask. I mean, it's fine. I can make him move, but I might play around a little. And you can see each time I move him, he's sitting somewhere else in the room, and he can begin walking. But you'll see because his collision mask is a little big, he gets stuck. So I might want to resize his collision mask. Okay? But it's pretty good. All right, so let's resize his collision mask. So I'm going to go back to my player. This is just cleaning things up a little. Open him up. And we're using sPlayer run down as our default sprite. So let's go into that, go into our player. sPlayer run down. And I'm going to take a look at his collision mask. And I might just shrink it down a little. Like so. And maybe I'll bring it up a little closer to his feet. Bring it in a little farther like so. And at this point, this is more of an art than anything. But let's take a look and see if that works better. So now here he is. Now he can move. Let's regenerate. Hey. Sorry, you can't see this. Let's move it up so you can see. Good. All right. So now he's not getting stuck. He's able to easily move around. I still think that I've got too many walls and long hallways and not enough open space in my room. So I'm going to go back to my level object, and I mentioned that what you can do when you are setting this up is update how many steps you want to include, right? So let's take this way up to like, I don't know, 1200. And let's take a look and see if that's going to give us too much of an open floor. We might adjust it. That's not bad, actually. It looks pretty good. Here we go. Here's our guy. Cruising along. Sweet. Looks good. All right, now we're getting quite close. Really the last thing we need to do now is to begin to place our enemies out inside the room. And believe it or not, placing our enemy in the room is kind of easier than everything else we've been doing. So let's go ahead and do that. All right, I'm going to pause, or I should say I'm going to take a step back before we begin putting our enemies in the room. Each time I go and test the level that I'm creating here in this video, I keep feeling like there's something amiss. We're seeing too many walls, and there's just something that's not quite right. So in the background here, I've been looking through all of my code to see if I can identify any problems. And I found one. All right, so here in the section, one of the things we did was we have a little piece where we didn't want the controller to go beyond the edge of the grid. And I'm not sure that will affect problems in here, but it is not quite set up the way I want it to be set up. And the reason it's not set up the way I want to be is you'll see what we've done here is we're checking to see if the controller X is either less than 2 or greater than the width of the grid minus 2. And if so, what we have is we're saying, well, just keep move it over a couple more, which is obviously not what we want. We actually want to back it up rather than move it farther over. That's sort of the opposite of what we want to do. So what I need to do in here is say minus X direction times 2 and minus Y direction times 2. I don't know that that will have any impact on how our room looks, but it will prevent weird issue. Oh gosh, it had a big impact. All right, so no wonder we're having a issue with the walls not quite showing up correctly. So now you see, now we got all kinds of open space in here, which is what I want. Oh, thank goodness. It was baffling me. So I'm going to come back. Again, we're pulling it back, so we're going minus in each of these cases. Right? And with that now, I've got sort of more steps than I really need. So I'm going to reduce this back down to, say, 600. And let's see what that looks like. And that should have us looking a little more like what we want. Oh, far better. Okay, thank goodness. I was flipping out, trying to figure out why my room was not looking the way I wanted it to. Now it looks about right. Okay. So, with that correction, let's go down all the way down to where we are placing our tiles. And we're going to come into this section and begin to place, well, let's start with our enemy. Okay, and here's how we're going to make this work. So we're here inside this walkthrough of our grid, placing the correct image for our tiles, placing wall objects. So I'm going to, before we leave this initial walkthrough, what I want to do is, I'm going here where I've got this inner check of an if, right? I'm going to come after that, and right in here, I'm going to place some enemies. Note the names of the objects should match the names in the resources. I'm putting this note in here because I sometimes get emails from students saying, I followed your video, I wrote the code, but it doesn't work. And often the problem is that the name that I use in the video over here might not match what you called your objects in your own version. So make sure that the names you're using in the code match the name of the objects that you used in your own project in the resources. Okay? All right. So to place our enemy, we need to do something kind of fancy again. And we're going to do this in a couple of steps. So we'll start with a relatively basic version, then I'm going to fancify it a little bit. So the relatively easy version is that we want to create a sort of multi-side virtual die, just like we've done earlier, that will determine whether or not we are going to place an object out in the room. So we've done this a bunch of times, so we're just going to create a local variable, and I'm going to call it item, let's call it enemy underscore odds, and I'll set it for now to 30. Remember that the higher the number, the less likely to appear. This means the higher this number is, the less likely it is we're going to have an enemy show up in our room. We're adding sides to our virtual die. Then what I want to do is I need to have an X and a Y position for an item that I want to place out in the room. Now we've been working with a data structure, a grid, that itself doesn't really have any sort of physical properties, right? It has a number of cells in it. So what we need to do is convert a cell position in our grid to a pixel X and Y coordinate in our room. So we need to translate a cell position to an X and Y coordinate. All right, so for the position, we will make a local variable. We're going to call it item X, and we're going to do the conversion now. We'll take our current position in the grid. We're going to multiply that by cell width, and we will add to that cell width divided by 2. And what that's going to do is, so this will convert whatever position we are in the grid to a location in the room by multiplying it by 32, right? Because we've got 32 pixel by 32 pixel cells is what we want to have in the grid. And then we're just adding half of the width of that to center it. That just comes from the origin point that we have on our items. All right, so let's copy that and we'll paste it in, and we'll set up a Y position using our Y position in the grid. Change this to cell height, and change this to cell height as well. Okay, so that gives us our custom X and Y position, but we haven't yet connected that to a real position out in the room. So we're going to need to do that here in a second. But let's take care of a few other things before we get there. Okay. So if we want to position this and we want to create it out into the room, where the heck and how the heck are we going to do that? All right, so let's check if we put an enemy out in the room. What we did in our RPG game, and I think in the platformer game as well, is we checked if the player and the enemy were within a certain distance from each other, we would go into an attack mode on the enemy, and the enemy would attack the player. We want to use something similar here to make sure that we don't plop an enemy down right on top of the player. That would be a little cruel if the player arrives in a level and they're surrounded by enemies who are attacking them. So we're only going to place an enemy in the room if they are on a floor, if our little roll of the die lands on a value that allows us to create an enemy, and if there is enough distance between the player and the enemy so that the player doesn't immediately get killed. So let's set all of that up in a big old if. So we're going to say if point distance, and the distance we want to check is the distance between this item that we're going to place. So item X, item Y, and then O player X and O player Y is greater than some value, take your pick. I'll say 120 pixels. Right? So it's only in the case that if the player and the enemy are at least 120 pixels apart from each other, that we even have the potential to place an enemy out into the room. And another check we want to know if we have our little virtual die has landed on the value that we set in odds. Enemy odds equals enemy odds. All right, so basically, we roll the dice. If it lands on 30, then we'll place an enemy out in the room. And how do we place an enemy out in the room? Well, we know how to do that. We are going to use instance, I can type, create layer, and what do we want to do with this instance create layer? Well, we're going to position it wherever we are now. So item X, item Y. We have to say which layer we want to put it on. We'll put it on the enemy layer. You should have that layer as that name inside your room, or update your script here to reflect which layer you want to place it on. And then which item do we want to put out there? We want to put the skeleton. Okay. Wonderful. So with just this part, assuming we haven't totally screwed things up, which is, you know, we'll have to see, we might have screwed things up, we can now place something out here. I feel like something's amiss here, so let's double check what's going on. We've got this here. I think we need to update to make sure we have the correct set of parentheses. So we got this set here. Yeah, we're missing stuff here. All right, if you're running into errors, just make sure that you have all of the correct matching braces. So here I've got a brace here, and it goes with that one. I've got a brace here. So we're just going to make sure we have all those set up correctly. There's more work we need to do with this, but let's just take a peek and see if this is going to produce for us some enemies out in our room. And oi, produces a whole bunch of enemies. You can see we have some weird issues with some of them, and that some of them are landing inside a wall, which obviously is not what we want. So we'll need to do a little fixing just to make sure that we don't end up with cases where our poor little guys are stuck inside the wall. But we can do that. So that's not bad, actually. Let's add in. Well, actually, let's take a look at what this problem is and see if we can fix it right now before we try to bring in anything else. You'll see that what's happening here is that for the most part we're okay, but every once in a while when it's placing one of these enemies out in the room, essentially because of the way we have set up the positioning of these enemies, coupled with their collision mask, they're ending up inside a wall. And the case where that's occurring is if there's a wall right below or right above our enemy, I think is the main issue. So we can take care of that, and one relatively easy way to take care of it is to only potentially place an item in the room if not only it's on a floor, which is what we're doing right now, but also we have floors all the way around it. So we're going to make sure there's at least one floor item to the left, top, right, and below before we could potentially place one of these guys out into the room. So how can I do that? Well, what I might do is, let's check. Here's where we're starting our enemy, right? We're doing all this within the inner for loop, walking through the grid. I'm going to come here, and I'm going to say, this is a little tricky, okay? I'm going to say if, let's look into our grid where we're sitting right now. So I'll use the accessor symbol, and I'm going to say if the grid's X and the grid's Y, right? That's right where we're at. We don't actually have to check the floor. If the grid's Y plus 1, meaning one spot below us in the grid, equals floor, right? And let's copy this. One space above us equals floor, and one space to the left of us equals floor, and one space to the right of us equals floor. If all of these things is true, then potentially we can place an item out in the room. To update all this to make sure that I'm getting my little matching brace, and then I'm putting all of this stuff inside there. So watch what happens when I do this. Now, first of all, we're going to have fewer enemies because we've added another condition, a rather restrictive condition, to placing an enemy out in the room, which is that it has to be surrounded on all sides by floors. But that still can give us quite a few of these guys, see? And now we're no longer having a case where they're stuck in the walls, which is what we want. Excellent. All right, so now we're pretty close. Let's do a few more bits and pieces in here to set all of this stuff up. I'm going to create a new odds, and we're going to go down within this if check to see if we've got floors all around us. And let's call this one, oh, how about plant odds. And we're going to set our plant odds to 1, meaning we've got a 50-50 shot of throwing a plant down in the room, given all these other conditions that it has to meet, making sure that there are only floor all around it. Okay. Then we want to place a plant, and so we're going to need to do our little random check, right? So let's grab this if that we just used for our enemy, and we're actually going to simplify it because we don't care about point distance anymore. We only care about this random. And now we want to know plant odds. If it equals plant odds, then we're going to create an instance of one of our plants on, in my game, I have a greenery layer, which I think you probably do too. Check to make sure you have this layer, or place it on any layer really, but for organizational sake, I'm placing it on the greenery layer. And obviously I don't want to produce a skeleton. What do I want? Well, I want a plant. Now I've got more than one kind of plant in my project. I've got grass and I've got a tree. So I want to randomly choose between those two. So in order to pull that off, I can actually use the built-in function called choose and then put in the stuff I want. If I put in O grass and O tree, it'll give me a 50-50 chance of getting those. But I'd actually like to have more grass than trees. So I'm going to up the odds. I'm going to weight this choose in favor of grass. And a simple way to do that is just to include multiple references to grass in the choose. Okay? So let me show you what that looks like. Now we got an error, so I'll have to double check. Oh, I missed the underscore at the beginning of my plant odds. So I can't find that variable. Well, make sure that when you initialize a variable that you use the same name when you're referring to it, otherwise GameMaker runs into trouble. And hey, this looks pretty good. Look at there. I can slash away at the plants. I'm not able to kill my trees. I can come up, get that guy, take that. I'm pretty happy with this. I guess the last thing I want to do here is let's copy this. What else do we want to place out here? How about pickups? Once you have the system in place for placing items out in the room and having odds associated with each of them, then this becomes really easy, right? You can just place essentially anything you want out in your room. We don't need choose. In my case, I only have one pickup, which is the strawberry. But you can certainly imagine a case where you've got all kinds of pickups that you want to have out into your room, and that you just keep adding them up. Oh, now right now I've got my pickup odds set to 1, so we're gonna have about a zillion strawberries. It's probably not quite what I want. So let's set our odds much higher for our strawberry. And we'll see what that looks like. That looks pretty good. We got a strawberry down here. Pick him up. That's basically it. I mean, we don't have a full game yet, but you can see we now can auto-generate these levels, auto-generate enemies, greenery, pickups, etc. There are lots and lots and lots of little tweaks that you can do to improve the way this looks, the way that it works. But this is not bad. It actually works pretty well. I think that's it. So I hope you enjoyed this. I hope you can make use of this auto-generation system for creating your own games.